We now look at what happens in the plane z equals 10. Now in that plane, our equation becomes 4x squared plus 9y squared minus 10 squared equals 36, so that 4x squared plus 9y squared equals approximately 136. 10 squared is 100, add 100 to both sides. So that the equation becomes, now we divide by 136, that's x squared divided by the square root of 136 over 4, quantity squared, plus y squared divided by the square root of 136 over 9, quantity squared, equals 1. Now the rearrangement from here to here is straightforward. Make sure you understand it. 136 over 4 is 24. The square root of 24 is almost 5. So let's say this is x squared over 4.9 squared. 136 divided by 9 is a little over 15, which is a little less than 16. Let's just say that this is 3.9 squared equals 1. Now what's the graph of this function look like? Well, it looks a whole lot like the graph of this function, except these numbers are somewhat bigger. And not sure what's how. Oh, that's 44. So my 4.9, these numbers aren't proportional to these, so my 4.9 should really be square root of 44 is around 6 point can't think about that and do this at the same time. Square root of 44 is going to be between 6 and 7, a little closer to 7, so I'm going to say this is about x squared over 6.6 squared. So in an xy plane, and I'm not going to call that xy, I'm going to call that x prime, y prime. The prime doesn't denote derivative, the prime simply denotes that it's like an xy plane, but I can't really call it xy because xy is down here in the z equals 0 plane of our three-dimensional space. And here we're in the plane z equals 10, so we have sort of a set of auxiliary xy axes. Now, this means that we're going to have to come out 6 units, 6.6 units, about this far in the positive x direction and an equal distance in the negative x direction. In the y direction we come up 3.9, almost 4 units. So come up to about here and down an equal distance here, and we sketch our box, and I think we need to move over a little bit. We need to, we then sketch our ellipse, which is going to look just a whole lot like the other one, but this picture's on a little different scale. The marks on my x-axis are closer together than they were up here, so that actually this picture is somewhat bigger than this picture. And we can correct that when we come up to our three-dimensional picture. We're going to move up 10 units in the z direction to z equals 10. Now I'm going to have to kind of compress my z scale, but let's just say that this point here is the z equals 10 point. And I'm going to draw my auxiliary x-axis with dotted lines. I'd better come out a little further than that because this thing's going to be a lot bigger than this one. In this direction, so there's my x prime axis, and my y prime axis. Now we can't read that, but let's not let that distract us too much. And here an x prime axis. Now in this direction, using marks spaced as they were here to keep the scale of this diagram consistent between these two planes, we're going to come out to about here in the y direction and about 1, 2, 3, 4, a little less than 4 units in the y direction here. So our rectangle is going to go parallel to the x prime axis, which is parallel to the x-axis, and through these points. And in the x prime direction, and the direction parallel to the x-axis, we've got to come out about 6.6 units if I've done my arithmetic correctly. So here's 6 units, and I'm going to say about here is 6.6 units. We come back here an equal distance, about 6.6 units, and we construct a rectangle very similar to the way we constructed the previous rectangle. We try to aim a more or less straight line in this direction. We come across in the x direction. We come back here till we intersect this line. We come across here. We're getting up into our equations here, but we can see how this rectangle is constructed, and I can draw most of the 4 sides. I have to kind of leave it off here so I don't write over my equations. But right here is a picture of this rectangle, and we understand this is in the plane z equals 10, centered on the z-axis, 10 units above the xy plane. And now we draw our ellipse here. Now I'm systematically drawing this distance bigger than this distance, and it really should not be so. It's just the way my eye happens to be working tonight, so if you do this, try to do it more accurately than I did. In any case, here's our ellipse. So what we see is in the xy plane we have an ellipse of this size. In the x prime y prime plane we have an ellipse with a scale about 1.5 times as big, and that plane lies 10 units above the xy plane. And these two ellipses are typical cross sections of this surface in 3-dimensional space.